Alright, so today is total review, except one little tiny new piece of information. But other than that, everything else is total review. So this is section 1.6. And of course, we're talking about graphical transformations. And when we talk about graphical transformations, this is where we're moving it right, left, up, down, stretch, compress, right, flip, all that wonderful stuff. Okay. So if I have a parent function, and remember we always use our parent function to translate from. So let's say I'm going to start with my parent function. Let's use y equals x squared as our parent function. All right. So then, there's a lot of different things we can do to this parent function. If I have y equals x squared plus k, that means that I'm translating it up, k units. If I have y equals x squared minus k, that means I'm going down k units. If I have y equals, and in with x, we have x minus h squared. We always said you can take what's in there, set it equal to 0 and solve it. It will tell you where you're going, right? So this is going to the right h units. If I have y equals x plus h squared, this goes to the left h units. Alright, if I have y equals ax squared, if the a is greater than 1, this is a stretch. Now when you look in this book, we call it a stretch. If I'm stretching up and down, or I'm stretching it up, this is called a vertical stretch. Just to clarify some of the stuff this book uses. If a is between 0 and 1, we say compress. Which means our function is getting wider, right? We're flattening it down. So that is considered a horizontal stretch. Now, I am okay if you say compress, but if you were to look in the back of the book and compare your answers, just so you realize, that's what they're saying. When they say horizontal stretch, they are saying you're compressing it down. You're making it flatter. Okay? Now, when we had y equals negative ax squared, that negative in the front of the function did a what? Yes, it flipped over x. Alright, so here is the only one we haven't talked about yet. Is if I have y equals a and then negative x squared. So the x itself is negative. When the x is negative, this flips over y. Alright, so any parent function you can do this to, right? All of them have basic functions that are being translated, stretched, moved, whatever it is. So here is example number 1, all fitting in with this. Example 1. Describe how y equals x squared translated given y equals 2 squared minus 7. So on this one, first of all, if you were to take this and set it equal to 0, that's one way we think about it, right? And we solve, it tells us that x is at negative 2. This means it's going to the left 2. Or you guys like to just look on the inside and say it's going opposite what it appears, right? Okay, what about this minus 7 on the end? Down 7, good. All right, so that was a pretty easy one. So let's try another one that's not quite as easy. Let's say I have y equals 1/3 2 minus x squared plus 1. Okay, so compress, or we can say a horizontal stretch, but we like compress, 1/3. Okay, flips over y. What else do you know? See, now this is where you got to be careful. It is right 2. Yep. So remember, you can take this, 2 minus x, set it equal to 0. Subtract 2, we get negative x equals negative 2, so x equals 2. So this goes to the right 2, maybe. And then the plus 1? Up 1. Very good. You guys are awesome. All right, so that's really what you are doing. Let's try the first 8. Well, I guess 2 through 8 is where it starts. Because all you're doing is you're looking at it, writing down what it has or what's happening. Okay? I know it looks like a lot. It's not that bad. Don't panic on me. It's not. It's going to be fine. All right, let's do example number 2. Example number 2. Let's say, describe how y equals the square root of x. Translated. If we have y equals the square root of x plus 4 minus 2. That's a 2. So in where x is, underneath our square root, that's telling us we're going which direction, how far? Left 4, very good. Left 4. And down 2, good. You see these aren't going to take very long, right? Okay. What if I had, I'm going to just change this up on you a little bit. What if I had y equals the square root of 4 minus x plus 3? Okay, we have up 3. I agree with that part. Right 4. Okay. Good. And it does flip over y. How do you know it flips over y? Yeah, the x is negative. So instead, if I had the square root of x, that's this one, that's just a graph that goes that way. If I have the square root of negative x, it's a graph that goes this way. Yeah, I guess that's one way to look at it. All right, so those are pretty easy. Okay, so let's try this. Example number 3. We're all the way up to 18 through 24. It says, describe how one graph together. So let's say I have f of x equals the square root of x plus 2, and I have g of x equals 3 square root of x minus 5. So to get from f to g, what are we going to do? I agree, we're going to stretch at 3. And then how do we decide how many we're going right or left? You're close. Right 7. Yes, it's right 7. So let's talk about why. This one started off as left 2. This one is right 5. So how do I get from left 2 all the way to right 5? I have to go right 7. Those seem pretty easy? Okay. All right. Let's go to example number 4. Describe how y equals the square root of x was translated. And I'm going to give you a graph that, let's see, I'll go like this. It's right there. Okay, so remember the square root of x starts here, right? So what's one thing it has to do in order to flip on or get onto the graphs they're showing us? Okay, I saw some people doing this, so it's flipping over the what? Flip over x, okay, flip over x, I agree. So that's going to take it to, from here, it's going to be down here, right? And then I have to go to the left how many? 1, and up how many? Good. So we're just going to say, whoop, maybe, left 1, and up 1. Didn't have to write an equation or anything, just tell me how it moved. All right. All right, so here's really what I want, because I think you guys can handle everything until we get to the new stuff, the only new stuff there is. Let's do this. We have 4 things that could happen. We have y equals the absolute value of f of x. We could see y equals f of the absolute value of x. We could see y equals negative f of absolute value of x. And last one, y equals the absolute value of f of the absolute value of x. Oops, there you go. Aren't those awesome? Alright, so here's how I want to describe it. What this simply means is that you're making it positive what they're talking about, okay? So in this first one, you're making the whole function positive, right? Because the whole thing's in the absolute value. So if I have a function that looks like this, so a picture drawn like this, I have a couple sections that are in the negative world right now, right? They're below the x-axis. This simply means that I have to make them positive. So I'm going to take my graph, and anything that was negative, I have to move to the positive. Here it went negative, I have to move it to the positive. That's it. So my graph actually is this piece that goes like this. It comes down, goes up, there's kind of a second little hill there, and then back up. It's just telling you what has to be positive. And in this case, the whole function had to be. All right. Second one, what has to be positive? The x values, right? So if it's the x values that have to be positive, if I have a graph that looks like this, I have negative x values right now. What do you think I have to do with those? Right? Because I have like a -1 is right here, -2, -3, and so on. What do you think I have to do with those? Yes, we have to flip it over the y-axis. You're right. So, you are. So this piece is actually going to flip over to this side and go that way instead of being here. Okay, let's talk about this one. What do you think this one did? And the negative's in front of that one. What does that do to your function when the negative's in the front? Yeah, so it's actually going to take this function that we kind of have, like this little fish-looking thing, right? And it would take that fish-looking thing and it'd flip it over. So we would end up with this fish-looking thing. Instead of it going this way, it would be steeper on this side and then steeper that way. And then how could I change? Let's actually get this back here. So here's my original function that I've been drawing, right? All right. So my whole function has to go positive. So that means this piece right here is going to go up this way. And this piece right here is going to go this way. So these are gone. This one and this one. Everybody good with that? Now, what do I have to do to make my x's all positive? Yeah. So instead of it being like this line straight down and over, it's actually going to be here. Kind of follows that same idea. Okay? You have 2 of them in your homework today. The 2 you have are the easy ones where you're just making it all above the x-axis. You don't have to flip over y, you just got to flip over x. All right? Let me just make sure. I think you guys can do the rest. I do. So if we run across some questions, that's what I'm here for, but I think you guys can handle the rest of them. It's all mostly review. So.